All right, in this one we're going to integrate cosine to the fifth of x, cosine to the fifth x dx. So similar to before, we're going to write cosine to the fifth x as even power times a linear power. And in the last one we did it with sine, and this time we're going to do it with cosine. And the reason is that cosine squared x plus sine squared x equals 1. We can do even powers of cosine, and it allows us to write it in terms of sine. And with this with this linear term left over, that means we have something to plug in for the u sub. So if that doesn't make sense, just follow along as we go through this. Okay, so I'm going to write this as the integral of cosine to the fourth x times cosine x dx. Okay, so that's just taking care of this part. Now, this part right here, I want to use this property. But note, cosine squared x squared is cosine to the fourth x. So that means that cosine squared and this cosine squared are going to be what I plug in. So this is going to equal 1 minus sine squared x squared. So I'm replacing this cosine squared with 1 minus sine squared x coming from the Pythagorean identity, and then I have to square that whole thing. Okay, because that's what gives me the cosine to the fourth power. Okay, so I'm going to substitute that in with that. 1 minus sine squared x squared cosine x dx. Okay? All right, so there's the final result. So now I just need to FOIL this out and then redistribute and use the linearity of the integral. Okay, so I'll go ahead and do that to here. 1 minus sine squared x squared is equal to, all right, so 1 minus sine squared x squared is equal to 1 minus 2 sine squared x plus sine to the fourth x. Okay, so that's just the result of FOILing this out. It's a perfectly square trinomial. Okay, so this is then what's going to replace this term in the integral, and then I'll have to multiply each of those by cosine x. Okay, all right, so this implies we have the integral of cosine, and the cosine of x is being multiplied from the cosine x to this 1 here, gives me the cosine x dx. Okay, and then I have minus, I factor out the 2, sine squared x cosine x dx. So that's coming from multiplying the cosine x times the minus 2 sine squared x, and then plus the integral of sine to the fourth x cosine x dx. Sine to the fourth x times sine to the fourth x times the cosine x coming from here. Okay. All right, so each of these terms I can integrate individually. Here I'm going to let u equal sine x, and then my du term is going to give me a negative sine x dx. Likewise here, I'm going to let u equal sine x, and du is going to give me a negative sine, oh, I said negative, huh? It's going to give me a positive cosine x. Sorry about that. Cosine x dx. Okay, that's not going to be negative, it's going to be positive cosine x. Okay, all right, so let's go ahead and plug this in. All right, so the integral of cosine of x, so this is equal to the integral of cosine of x is sine of x, and then I have minus 2 times the integral of u du squared plus the integral of u to the fourth du. Having plugged those in, the cosine integrated right away. Okay, and so integrating here, I'm going to get sine of x minus 2/3 u cubed plus 1/5 u to the fifth plus a constant. And then substituting back in, I'm going to get that, and putting it in decreasing order of power. So I have 1/5 sine to the fifth of x minus 2/3 sine cubed of x plus sine of x plus a constant. Okay, all right. So that's all there is to this one. I hope that was helpful, and I'll see you in the next video.